Hello. Okay, today we are going to be talking about magnetism. So, what even is magnetism? It is a group of properties and interactions of magnets. So, the earliest magnets that we know of were found naturally in the mineral magnetite. It's an abundant mineral in the rock called lodestone. But these magnets were used by ancient peoples as compasses to guide their sailing vessels. Magnets produce magnetic forces and also have magnetic field lines like the ones you see here, which we see are strongest near the poles and weakest in the middle. So magnets have two ends or poles called the north and south poles. At the poles of a magnet, that's where the magnetic lines are closest together and the magnetic strength is greatest. Like poles are going to repel each other and unlike poles are going to attract. So south and south would not attract, they would repel. Unlike poles, north and south would attract. So the Earth is like a giant magnet because of our nickel iron core, and we have a magnetic field, which is why compasses do work to direct us north or south, east or west, wherever we are trying to go. If we're looking at a compass, it'll tell us which direction we're going in. And what are our magnetic domains? Well, iron, cobalt, and nickel, they're all magnetic, and they have small areas where the groups of atoms are aligned at the poles. These regions, they call them domains, and all of them have, all things that have a magnetic substance tend to align themselves in the same direction when they're placed in a magnetic field. So, if you look at image B, you can see all of these, the domains are going to align themselves when they're placed near a magnet. Now, we know an iron nail is not magnetic, which is why you see these not lined up perfectly. When we place a magnet near another magnetic object, the domains are going to align themselves. All souths are pointing up, all norths are pointing down, south and north are near each other. So how do we relate electricity and magnetism? Why do we talk about them together? When an electric current passes through a wire, we form a magnetic field. You've probably made one of these before where you wrap copper wire around a nail and attach it to a battery. It becomes magnetized. Even though those two things are not magnetic, when they have a current passing through them, we form a magnetic field and it can pick up all sorts of things. So what is an electromagnet? An electromagnet is where you have an electric current pass through a coil of wire, here's the wire, wrapped around a metal core. If it's not attached to a battery or a power source, we won't see any magnetic properties. So what are electric motors? A motor is driven, is a device that changes electrical energy to mechanical energy. And it gets this electrical energy from a battery. Think about your car. Your car motor gets its power from a battery. We've got a permanent magnet around this electromagnet where the electron flow is. Okay, this is our simplest electromagnet and electric force in our compared to, electric generators. But as we talk about motors, one thing I want you to notice is that you have a permanent magnet that does not switch. We've got north on top, south on bottom, south on bottom. We've got our battery source. It stays perfectly still. Produces a direct current. But when you've got your electromagnet in the middle, the metal core with the wire coiled around it, what we notice is when it starts to spin, it only spins because of the flow of electrons from the battery. So in a motor, our electromagnet is spinning because of the electrical energy from the battery. So the battery causes the current to flow and it causes the electromagnet to spin. So when the current inside the coil is switched up and down, backwards and forwards, they trade places between north and south, south and north. The coil in the middle is repelled and attracted by the poles of the permanent magnet, and it creates this magnetic field. Now, how is electricity producing a magnetic field, but a magnetic field is also going to be used to produce electricity. Well, we have a thing called electromagnetic induction. We just talked about the electromagnet being the core of metal wrapped with a wire and attached to a battery. But moving a loop of wire through a magnetic field we know produces a current. This is called electromagnetic induction. So a generator can sort of do the opposite of what our motor did. A generator is used to convert mechanical energy, so the spinning of that electromagnet, into electrical energy by electromagnetic induction. So notice the difference here. Instead of a battery, we have a hand using mechanical energy. So in the other image with the motor, the battery was what was spinning this electromagnet. So the battery, the chemical energy, the electrical energy, was creating a magnetic field. Here, we are going to physically create the magnetic field by spinning this electromagnet inside of the permanent magnet, and that is going to create electricity. So, in a generator, there is a form of mechanical energy. The direction that the current flows in a wire depends on how it's aligned with the permanent magnet. So, if you've got a light bulb attached and you start spinning it, you can see this electromagnet going backwards and forwards. So, the last thing we're going to talk about is a direct current versus an alternating current. A direct current comes from a battery. It's an electrical current that comes from a battery that supplies a constant flow in one direction. Alternating, like we saw with the generator, is where the spinning or changing directions, alternating, creates the current. So what I want you to do is I want you to look in your packets at page 13. If you look at page 13, at the top it says electricity and magnetism. When a current is passed through a coil of wire with a piece of iron inside of it, we create what you saw in that motor and generator, which is called an electromagnet. An electromagnet is a temporary magnet. We made it out of a nail, per se, and copper wire attached to a battery. If we add more wire coil, we're going to increase the strength because there's more current flowing. If we increase the amount of current flowing, it increases the strength of the electromagnet because we're increasing the current. Electromagnets change electrical energy into mechanical energy, as it did in the motor. It spins. An instrument that is used to detect current is called a galvanometer. An electric motor, think of the first one with the battery, is going to change chemical energy from the battery into mechanical energy. Like a galvanometer, an electric motor contains an electromagnet that is free to rotate between the poles of a permanent fixed magnet. A coil's magnetic field can be flipped by reversing the direction of the current. Now, in a motor, we have a reversing switch that rotates with an electromagnet, and it is called a commutator. In a motor, the stronger the magnetic field in the coil, the stronger the force between the permanent magnet and the electromagnet. The speed of an electric motor can be controlled by varying the amount of electric current to the motor. So if we name 3 devices that use motors, I want you to go ahead and tell me 3 things that might have a motor in them. Like I would say a refrigerator, a car. Think of anything with a motor inside. And honestly, electricity and magnetism are even related we talked about generators just a second ago. So we could think a regular generator for your house. Think of anything with a motor or generator and write it down for number 13. Now, we're also going to flip to the back, page 14. We see the hand here. I automatically know if we're going to be rotating this first using mechanical energy first, this is the source of mechanical energy, then I know that this is going to be a generator. We're not using a battery like we use in a motor. We're using mechanical energy, which is a sign that it's a generator. Now our electromagnet is the metal wrapped in wire, so that's going to be our electromagnet. And then lastly, our permanent magnet is the one that stays fixed on the outside. Okay, now we're going to answer some questions. Is this a motor or a generator? It is a generator because we aren't using a battery to power it, we're using mechanical energy. So when the wire loop of a generator turns, electric current is produced. In the motor, remember, the current produces the turning. So a generator is really doing the opposite thing. So in a generator, the current produced is alternating because this electromagnet alternating back and forth is what's creating the current. A motor creates an electric current as it turns. Oh, I'm sorry. No, that's a generator. A generator is what's creating it. A motor uses electric current from the battery. A device that increases or decreases voltage passing through a power line is called a transformer. You have transformers near your house. Sometimes people will say transformers blow during a storm. Transformers are what we see making power that comes from a power line accessible and usable for your home. So sometimes they're step up or step down, and depending on what kind of home you have and how much power you need or electricity you need. So if the secondary coil of a transformer has more turns than the primary coil, we call that a step up because the second one has more coils than the first one. All right, here we're going to draw a step down transformer that has half as many coils in the second coil. So let's say I have two coils. I'm going to draw them right here. First coil, second coil. So all right, second and first. We want this to be a step down. So it's going to have half as many coils in the second. So in the first one, if I have 1, 2, 3, 4, 5, 6, in the second one, I'm going to have 1, 2, 3. 6 and 3. All right, now what I want you to do is I want you to turn back to page 4. Okay, let's look at page 4. Okay, when we look at page 4, we are going to draw our triangle, which is voltage is current times resistance. Resistance is measured in ohms, represented by the omega symbol. Volts are the units for voltage, and current is measured in amps. So you are going to do these together. The first thing we're going to do, remember, is we have ohms. It's at the bottom. You must draw your triangle to get credit. 24 volts. 24 divided by 12 equals 2. So my current equals 2 amps. Be sure you put your unit and be sure you put the letter of the thing that you were looking for. In this case, it was current. So number 2 says we want to find the resistance. So I am wanting to find R. We have 0.6 amps. I see that amps, and that's amperes. 0.06 goes there, and 12 goes on top because it's volts. 12 divided by 0.06. You are going to find that answer with your calculator as well as the other ones. Be sure you draw it in the triangle. You're finding resistance. So when you find that answer, don't forget that it is going to be in ohms. Okay? So once you finish that, you should be done if we have time.